below. In this lecture we'll find out the green area using two different methods. In the drawing we have a quarter circle. Here A or B is a quarter circle, and inside this quarter circle we have quadrilateral ACDO, and our mission is to find out the area of this quadrilateral ACOD. It is the green area. In addition, we know that line side AC equals to 24 units in its length, side CD equals to 7 units in its length, and this angle ACD equals to 90 degrees. And again, our mission is to find out the green area that is actually quadrilateral AODC. We start with the first method. First of all, because of the fact that AOB is a quarter circle, it means that angle AOB, this angle equals to 90 degrees. And point O is the center of the circle that we can create by completing this quarter circle to a circle. Okay? So from point O, that is the circle that we can create here, we draw perpendicular on AC. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC as P. And here we can implement rule number 11. According to this rule number 11, the perpendicular to a chord drawn from the center of the circle bisect the chord. Point O is the center of the circle. OM is the perpendicular to AB. That is to say, it is given us in the drawing that this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. So whenever you have a perpendicular from the center of the circle to any chord, like here, OM is drawn from point O, that is the center of the circle, and it is actually perpendicular to chord AB, then OM will not only perpendicular to AB, but it will be also bisect a chord AB. That is to say, AM equals to MB. So according to this rule, whenever OM is perpendicular to AB, then OM will also bisect AB. That is to say, AM equals to MB. We can implement rule number 11 in our drawing. Why? Because in our drawing, from the center of the circle that we can create by completing this quarter circle to a circle, that is to say, from point O, we have perpendicular OP on chord AC. Whenever you have from the center of the circle perpendicular towards chord AC, that is to say, we know that this angle equals to 90 degrees and this angle equals to 90 degrees. Then according to rule number 11, the perpendicular OP also bisects chord AC. That is to say, AP equals to PC. So the first half of AC is AP and the second half of AC is PC. And because of the fact that AC in total equals to 24, the first half of 24 is AP, that is 24 over 2, that is 12. So AP equals to 12. And the second half of AC is PC, that is also of course 12. So this is the implementation of rule number 11 in our domino. You can see here that the perpendicular from the center of the circle OP is perpendicular to AC. Therefore OP, according to rule number 11, will also bisect chord AC. That is to say, it will divide chord AC into two halves. The first half is AP, that is 24 over 2, that is 12, and the second half will be PC, that is also will be equal to 12 units. Okay. In the next step, from point D, we will draw perpendicular on OP. Again, from point D, we will draw perpendicular on OP. So, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point D and OP as Q. So created here quadrilateral QPCD. This quadrilateral has 1, 2, 3 right angles. The sum of right angles is 90 times 3 is 270 degrees plus the fourth angle. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. Again, in order to complete the sum of the angles in this quadrilateral PCDQ to 360 degrees, the missing angle here must be equal to 90 degrees. So inside quadrilateral PCDQ, we have actually 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square, so we relate to quadrilateral QPCD as a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. That is to say, DC equals to QP, but DC is 7, therefore QP must be also equal to 7. Likewise, in rectangle PCDQ, PC must be equal to QD, but PC is 12, therefore QD must be also equal to 12. We define the length of chord of line segment OQ as X. We define angle QDO, this angle as alpha. So inside the right triangle OQD, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is 180 degrees, that is the sum of the angles in any triangle. So this angle must be equal to 90 degrees minus alpha. We will define 90 degrees minus alpha as beta, that is to say it is equals to beta according to our definition. So we can substitute 90 degrees minus alpha here by beta, because beta equals to 90 degrees minus alpha. So angle P, angle Q, O, D, this angle equals to beta. In total, angle AOB equals to 90 degrees, because AOB is the quarter circle. So angle AOB is a quarter circle, and therefore angle AOB equals to 90 degrees. Angle POD equals to beta. So 90 degrees, that is angle AOB minus beta, must be equal to the missing angle, angle AOP. I will write it down. 90 degrees, that is angle AOB, minus this angle, that is beta. It must be equal to the missing angle here, angle AOP. So it is 90 degrees minus beta, and beta is 90 degrees minus alpha. So we substitute here beta by 90 degrees minus alpha. We'll open the brackets here. We have 90 degrees minus 90 degrees is 0, minus times minus is plus, so in total this expression equals to alpha. So we found out that the missing angle here is equal angle AOP equals to alpha. So in the right triangle AOP, this angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha is beta, so we can write here that this angle equals to beta. So in the next step, we'll focus on the right triangle QOD. So I'll copy the right triangle QOD in a new page, and we'll find out the tangent alpha of the right triangle QOD. QD equals to 12 units. OD equal QO equals to X. So actually, this is the right triangle QOD that I copied from the original drawing. This angle equals to alpha. So in this right triangle QOD, copied from the original drawing, tangent alpha will be equal to QO over QD. It again, in this right triangle QOD, tangent alpha equals to QO over QD. That is to say, QO equals to X, so we substitute QO by X, and QD equals to 12, so we substitute QD by 12. In conclusion, we found out that in the right triangle QOD, tangent alpha equals to X over 12. This is equation number 1. In the next step, we will focus on the right triangle AOP. So I'll copy the right triangle AOP in a new page. What is the size, the length of PO? PO equals to PQ plus QO. That is to say, PO equals to PQ, that is 7, plus QO, that is X. So in total, PO equals to X plus 7. And AP equals to 12. So actually, this is the right triangle APO that I copied from the original drawing. PO equals to X plus 7 and AP equals to 12. In this right triangle, this angle equals to alpha. Therefore, tangent alpha in the right triangle APO. This will be equation number 2. Tangent alpha in the right triangle APO will be equal to AP over PO. AP equals to 12 and PO equals to X plus 7. That is to say, we actually found out that tangent alpha in the right triangle APO equals to 12 over X plus 7. This is according to equation number 2, and according to equation number 1, we found out that tangent alpha equals also to x over 12. So we have two different expressions for tangent alpha. In the next step, we'll create equation number 3. It states that tangent alpha, according to equation number 1, must be equal to tangent alpha according to equation number 2. That is to say, so tangent alpha according to equation number 1 is equal to x over 12, and it must be equal to tangent alpha according to equation number 2, that is equal to 12 over x plus 7. Conclusion found out that according to equation number 3, x over 12 equals to 12 over x plus 7. Here we cross multiply this equation, and we get that x times x plus 7 equals to 12 squared, that is 144. Here we'll open the brackets on this side of the equation, and we get that x times x is x squared plus 7x, that is equals to 144. Here we'll subtract 144 from this equation, and we get that x squared plus 7x minus 144 equals to 0. So we have here a quadratic equation. The general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. In our specific quadratic equation, the coefficient a equals to 1, the coefficient b equals to 7, and finally the coefficient c equals to minus 144. And the solution to a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. This equation, a, b, and c are the coefficients of the quadratic equation that we have already found out in our specific quadratic equation. So we put the data inside this equation in order to find out the value or the values of x. And we get that x, I should remind you that x is the length of line segment QO. Okay, so x equals to minus b. B is 7, so minus b is minus 7, plus minus square root of b squared. B is 7, so b squared is 7 squared, that is 49. Minus 4 times a is 1, times c, that is minus 144, divided by 2a. A is 1, so 2 times 1 is 2. So here x equals to minus 7 plus minus 4 times minus 144 is 576 plus 49, in total it is 625. So inside the root we have to live with 625 over 2. So here x equals to minus 7 plus minus, the square root of 625 is 25 over 2. So here we'll have two solutions that are possible for x. The first solution is x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32 over 2. Minus 32 over 2 is minus 16. So I found out that according to the first solution, x equals to minus 16, but because of the fact that ax is the length of line segment QO, ax as a length must be a positive number. So we cancel this solution, it is a negative, and we left only with the second solution to this quadratic equation, is that x equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So we found out that finally that x equals to 9 units. Here, x equals to 9 units. That is, say, the length of line segment QO is 9 units. So our mission is to find out the area of this green shape that is actually quadrilateral ACDQ. We divide the area into 3 areas. The area of the right triangle APO that we will define as A1, plus the area of the right triangle OQD that we will define as A2, plus the area of rectangle PQDC that we will define as A3. It is very easy to see that the total area of the green shape equals to A1 plus A2 plus A3. Okay? So we'll find out the area of the right triangle APO, that is the area that we defined as A1. So I'll copy the right triangle APO here. The length of side AP is 12. We've already found out that PO equals to x plus 7, but x is 9, so x plus 7 is 9 plus 7, that is 16, so PO in total equals to 16 units. So the area A1 is actually the area of the right triangle APO. The area of this triangle equals to, so it is A1, that is equals to the base is AP, times the height of the base is PO over 2. So AP is 12, PO is 16 over 2. 16 over 2 is 8, so in total this expression equals to 8 times 12. 8 times 12 is 96. So in conclusion, we found out that A1 equals to 96 square units. This is the area A1. It's actually the area of the right triangle APO. In the next step, we find out the area A2, that is actually the area of the right triangle OQD. So I'll copy the right triangle OQD in a new page, and we find the area of this right triangle. QD equals to 12 units in its length. QO equals to x, and we just right now found out that x equals to 9, so QO is 9. So actually, this is the right triangle OQD that they come from the original domain. QD equals to 12 and OQ equals to 9. So this is the area A2, and is equal to the area of this right triangle QOD. So the area of this right triangle equals to OQ, that is the base, times QD, that is the height, over 2. OQ is 9 times Q that is 12 over 2. 12 over 2 is 6, so in total this expression equals to 6 times 9, that is 54. In conclusion, we found out that the value of the A2 equals to 54 square units. And finally, we find out the area of A3. A3, it is equals to the area of rectangle QP CD. So the area of rectangle QP CD is equal to the length of the rectangle times the width. The length is PC and the width is QP. PC equals to 12 and the width QP equals to 7. So in total the area A3 equals to 12 times 7, that is 84. A3 equals to 84 square units. And as I already mentioned before, the area of the green shape of this green shape in total equals to A1 plus A2 plus A3. A1 plus A2 plus A3. That is to say, A1 equals to 96 plus A2 equals to 54 plus A3, that is 84. 96 plus 54 it is 150, and 150 plus 84 is 234. In conclusion, we found out the area of the green shape is equal to 234 square units. And that is the answer to our question. The area of this green shape equals to 233 square units. In the next step, I will present you a second method to find out the area of this green shape. Okay. In the second method, we join points A and D together by a straight line. This way we created the right triangle ADC. We'll implement the Pythagoras theorem on this right triangle ADC, so I'll copy the right triangle ADC in a new page, and we'll implement on it the Pythagoras theorem. Angle ACD equals to 90 degrees. So actually, this is the right triangle ACD that I copied from the original drawing. My PT is the version for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle ACD, AD square equals to DC square plus AC square. Again, DC equals to 7 and AC equals to 24 according to what is given us in the question. So AD squared, that is the square of the hypotenuse, equals to DC squared. DC is 7, therefore DC squared is 7 squared, that is 49, plus AC squared. AC is 24, therefore AC squared is 24 squared, that is 576. In conclusion, we found out that AD squared equals to 49 plus 576. In total, it is equals to 625. We'll take a root out of this equation and we find out that AD equals to the square root of 625, that is 25. Therefore, AD equals to 25. So we can write here that the hypotenuse here AD equals to 25 units. In the next step, we'll complete this quarter circle to a circle. So completed the quarter circle to a circle. Point O is the center of the quarter circle. Point A is the point of the quarter. Point O is the center of the circle. Point A is the point of the circle itself. Therefore, OA is the radius of this circle. We will define the radius of this circle as R. We will extend the radius AO until it touches the circle, and we will define the touching point of the extended AO radius with this circle as M. AM is a chord that passes through point O, that is the center of the circle, and any chord that passes through the center of the circle must be the diameter of the circle. That is to say, we found out actually that AM is the diameter of the circle. Likewise, point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of the circle, that is R, and indeed we can see that AM is the diameter of the circle because it equals to R plus R, that is 2R. AM is the diameter of the circle, that is equal to 2R. In the next step, we'll extend side DC by straight line until it touches the circle. So we don't know where the extended side CD will touch the circle. We will assume that the extended side CD will not touch the circle at point M, but in another point. For example, we will assume that the extended CD will touch the circle at this point, point N. So we will have peripheral angle ACDN that is equal to 90 degrees according to what is given as the equation. But the peripheral angle ACDN that is equal to 90 degrees rests on chord AN and not an AM that is the diameter of the circle. But it is actually contradicts rule number 5 that states that any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here we have the peripheral angle NAM or NAM that is equal to 90 degrees. This peripheral angle rests on chord NM that is the diameter of the circle. So according to this rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. But here we have peripheral angle NCDN that is indeed equals to 90 degrees, and still it doesn't rest on AM, that is the diameter of the circle. So it contradicts rule number 5. That is to say, we conclude that the extended CD cannot touch the circle at point N. Why? Because then it will contradict rule number 5, because we have then peripheral angle is CDN that is equal to 90 degrees, and still it doesn't rest on any M, that is the diameter of the circle. In order to avoid the contradiction to rule number 5, we must conclude that the extended CD must touch the circle at point M and only at point M and not in any other point. And here we have peripheral angle ACM that is equal to 90 degrees, and indeed this peripheral angle that is equal to 90 degrees rests on chord AM, that is the diameter of this circle, exactly according to rule number 5. Okay? So, because of the fact that AOB is a quarter circle, this angle will always be equal to 90 degrees. In any quarter circle, this angle must be equal to 90 degrees. Okay? So we'll focus on this side of the diameter AM, this of the diameter AM at point O. Which angles we have at this side of the diameter AM at point O? We have this angle that is equal to 90 degrees, plus the missing angle, in total they must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles on this side of the diameter AM at point O to 180 degrees, the missing angle here must be equal to 90 degrees. In the next step, we will prove that the right triangle AOADO is congruent to the right triangle ODM. Repeat again, the right triangle ADO is congruent to the right triangle ODM. So why those two right triangles congruent to each other? Those two right triangles. First of all, AO equals to OM equals to R. They are both the radii of the circle, therefore they are equal to each other. AO equals to OM equals to R. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle AOD is equal to this angle MOD. Repeat again, angle AOD equals to angle MOD, they are both equal to 90 degrees, therefore they are equal to each other. And finally, side OD is a common side that belongs to both triangles, so OD equals to itself. OD equals to OD is a common side that belongs to both triangles. Repeat again. OD equals to OD is a common side. So actually found out that the right triangle ADO is congruent, this is the sign of congruent, to the right triangle ODM according to side angle side rule. Those two sides are equal to each other. We have a common side and we have those two angles that are equal to each other. So those two triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we derive that AD equals to DM. AD equals to DM. why AD equals to DM? It is according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other according to side angle side rule. Therefore, the corresponding angles at the corresponding sides AD and DM must be also equal to each other. But here AD equals to 25, so we can write here that AD equals to 25, and from this equation 25 equals to AD equals to DM, we will derive that DM is also equals to 25. DM equals to 25, here this side DM equals to 25. So what is the length of CM? CM equals to CD plus DM. Okay. Why CM is a straight line? CM is a straight line because we extended side CD. We extended side CD by straight line. When you extend the straight line by straight line, the result is a straight line. So CM is a straight line. Therefore, CM equals to CD plus DM. That is to say, CM equals to CD, that is 7 plus DM, that is 25. In total, CM equals to 7 plus 25, that is 32. So I copy the right triangle ACM in a new page and we implement on this right triangle ACM the Pythagoras theorem. AM is the diameter of this circle that equals of course to 2r, and AC equals to 24 according to what is given us the question. So the right triangle ACM So actually, this is the right triangle ACM that I copied from the original drawing. In this right triangle ACM, repeat is a version from Pythagoras theorem. According to the Pythagoras theorem, we get that AM square equals to AC square plus MC square. Okay, so AM square, AM is 2r, therefore AM square is 2r squared, that is 4r square. And it is equal to AC square. AC is 24, therefore AC square is 24 squared, that is 576. Plus MC square. MC is 32, therefore MC square is 32 squared, that is 1024. In conclusion, found out that 4r squared equals to 576 plus 1024 equals exactly to 1600. So 4r squared equals to 1600. We divide this equation by 4 and we get that r squared equals to 1600 over 4 is 400. We take a root out of this equation and we get that r equals to the square root of 400, that is 20. The radius of this circle, r equals to 20 units. R equals to 20 units. What is the area of this green shape? The area of the green shape equals to the area of the right triangle AOD plus the area of the right triangle ADC. We'll define the area of the right triangle AOD as A1, and we'll define the area of the right triangle ADC as A2. Therefore, the area of the green shape will be equal to A1 plus A2. But first of all, we'll find the side OD of the right triangle AOD by implementing the Pythagoras theorem on this right triangle AOD. So I copy the right triangle AOD in a new page and we will implement on this right triangle AOD the Pythagoras theorem. According to the Pythagoras theorem, we get that in the right triangle AOD, AO equals to 20 units. It is the radius of the circle. The hypotenuse AD equals to 25. So actually, this is the right triangle AOD. This is the right triangle AOD. There's a copy from the original drawing. Again, AO is the radius, that is 20, and the hypotenuse AD equals to 25. According to the Pythagoras theorem, in the right triangle AOD, AD square equals to AO square plus OD square, that is the missing side. AD is 25, therefore OD square is 25 squared, that is 625, and it is equal to AO square. AO is 20, therefore AO square is 20 squared, that is 400, plus OD square. OD is the missing side, so we leave it as it is. We subtract 400 from this equation, we get that 624 minus 400 is 225, that is equals to OD square. Here we take a root out of this equation, and we get that OD equals to the square root of 225, that is 15. So we found out that here OD, this side equals to 15 units in its length. Now it is very easy to find out the area of this right triangle AOD. That is the value of A1. A1 equals to the base of the triangle, that is 15, times the height to the base, that is 20, over 2. We can find out that the area of the right triangle AOD, that is A1, equals to 15 times 20, that is 300 over 2, that is 150. In total, A1 equals to 150 square units. Now we find out the area A2, that is actually the area of the right triangle ACD. The area equals to the base, that is 7. A2 equals to 7 times the height AC, that is 24, over 2. That is the area of the right triangle ACD, that is actually A2. So A2 equals to 7 times 24 over 2. 24 over 2 is 12. In total, this expression equals to 12 times 7, that is actually 84. We found out that A2 equals to 84 square units, and A1 equals to 150 square units. So the area of the green shape in total will be equal to A1 plus A2. That is to say it is equal to A1, that is 150, plus A2, that is 84. 150 plus 84 is 234 square units. So we found out that the area of the green shape equals to 234 square units, exactly as we found in the first method. In the next step, we summarize the lecture. We start with the first method, of course. So, in this lecture, we found out the area of the green shape. In the drawing, we have a quarter circle AOB. This is a quarter circle. Inside the quarter circle, we have quadrilateral ACDO, and we actually want to find out the area of the quadrilateral. This is actually the area of the green shape. In addition, we know that side AC of quadrilateral ACD O equals to 24 units in its length, side AC equals to 7 units in its length, and this angle ACD equals to 90 degrees. Again, our mission is to find out the area of the green shape, that is actually the area of quadrilateral ACDO. Because of the fact that AOB is a quarter circle, this angle will always be equal to 90 degrees. Angle AOB will always be equal to 90 degrees. And point O will always be the center of the circle that we can create by completing this quarter circle to a circle. Okay. So again, this angle equals to 90 degrees, and point O is the center of the circle that we create by completing the quarter circle to a circle. From point O, that is the center of the circle, we draw perpendicular on chord AC. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and ACSP. So here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of a circle bisect the chord. Point O is the center of the circle. From point O we draw perpendicular OM on AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. So whenever you have a perpendicular from the center of the circle towards any chord, here we have perpendicular OM to chord AB, then OM will not be only perpendicular to AB, but OM also bisect AB. That is to say, here AM must be equal to MB according to this rule, rule number 11. We can implement rule number 11 in our drawing. Why? Because in our drawing we have point O in the center of the circle that we can create by completing this quarter circle to a circle. From point O, that is the center of the circle, we draw perpendicular on AC. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. So according to rule number 11, OP will not be only perpendicular to AC, but it will also bisect AC. That is to say, AP will be equal to PC. And because of the fact that AC in total equals to 24, the first half will be 24 over 2, that is 12, and the second half will be also 12. So AP equals to 12 and PC equals to 12. This is the implementation of rule number 11 in our drawing. In the next step, from point D, we draw perpendicular on PO. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. In this way, we created quadrilateral PCDQ. Inside quadrilateral PCDQ, we have 1, 2, 3 right angles. The sum of right angles is 270 degrees, plus the fourth angle. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. So inside quadrilateral PCDQ we have 4 right angles, and therefore we relate to quadrilateral PCDQ as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, DC equals to PQ, but DC is 7, therefore PQ must be also equal to 7. Likewise, in rectangle PCDQ, PC must be equal to QD, but PC is 12, therefore QD must be also equal to 12, according to the same rule that the opposite sides of a rectangle are equal to each other. In the next step, we defined the length of this line segment QO as X. Then we define this in the right triangle OQD, we define this angle ODQ as alpha. This angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. This is the sum of the angles in any triangle. So this angle equals to 90 degrees minus alpha, but we define 90 degrees minus alpha as beta. Therefore, we can write here instead of 90 degrees minus alpha beta. So we know that AOB, this angle AOB equals to 90 degrees because AOB is a quarter circle. This angle in total AOB equals to 90 degrees. Part of angle AOB is angle beta. Therefore, the missing angle here must be equal to the big angle AOB, that is 90 degrees, minus beta. The missing angle here is 90 degrees minus beta. AOP equals to 90 degrees minus beta. So it is 90 degrees minus beta, but beta is 90 degrees minus alpha. So we can substitute beta here by 90 degrees minus alpha. And we open the brackets here, 90 degrees minus 90 degrees is 0. Minus times minus is plus, so in total this expression equals to alpha. So we found out that the missing angle here, angle AOP equals to alpha, In the right triangle AOP, this angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta. So we can substitute 90 degrees minus alpha here by beta. Okay, then we focus on the right triangle OQD. So we copy this right triangle OQD in a new page. This is the right triangle OQD that I copied from the original drawing. This angle equals to alpha. OQ equals to x according to our definition, and QD equals to 12. In this triangle OQD, tangent alpha equals to QO over QD. Tangent alpha equals to QO over QD. QO equals to x and QD equals to 12. So in total, tangent alpha equals to x over 12. Then we focused on the right triangle APO. So I copied the right triangle here. This is the right triangle APO that I copied from the original drawing. AP equals to 12. PQ equals to, what is PO? PO is PQ plus QO. That is to say PO equals to PO that is 7 plus QO that is x. So in total PO equals to x plus 7. PO equals to x plus 7, AP equals to 12, and this is angle alpha. In triangle APO, tangent alpha must be equal to AP over PO. And tangent alpha equals to AP over PO. AP is 12, PO is x plus 7, so in total we found out that according to equation number 2, in the right triangle APO, tangent alpha equals to 12 over x plus 7, but according to equation number 1, tangent alpha equals to x over 12. So we have two different expressions for tangent alpha. Therefore, we created expression or equation number 3 that states that tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 1 is x over 12. And it must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 2 is 12 over x plus 7. So finally, we found out that according to equation number 3, x over 12 equals to 12 over x over 7. Here we cross multiply this equation and found out that x times x plus 7 equals to 12 times 12, that is 144. We open the brackets here and found out that x times x is x squared plus x times 7 is 7x, that's equal to 144. We subtracted 144 from this equation and found out that x squared plus 7x minus 144 equals to 0. This is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. In our specific quadratic equation, the coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144. And we find out the value of x according to a special formula. X will be equal to minus b plus minus the square root of b squared minus 4 times ac over 2a. Now the only thing that is left to do is to put the values of a, b, and c in this equation in order to find out the value of x. And we remind you that x equals to the length of right segment QO. So here x equals to minus b, b is 7, so minus b is minus 7, plus minus the square root of b squared. B is 7, so b squared is 7 squared, that is 49, minus 4 times a is 1, times c, that is minus 144. So we have here x equals to minus 7 plus minus minus 4 times minus 144 is 576, plus 49 in total. Inside the roots we have left with 625 over 2. So actually found out that x equals to minus 7 plus minus, and the square root of 625 is 25. So in conclusion we found out that x equals to minus 7 plus minus 25 over 2. So here we have two solutions that are possible for x. The first solution is x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32 over 2. Minus 32 over 2 is minus 16. So we found out that the value of x is minus 16, that is a negative number, but x is the length of line segment QO, and as a length it must be a positive number. So we cancel the solution that is x is negative, and we left only with the second solution that is possible, that x equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is x. So in conclusion, we found out that x, the length of line segment QO, that is x, it is equal to 9 units. Okay, now our mission is to find out the area of this green shape. We will divide the area of this green shape into three parts, and we will calculate the area of each part, and then we will add the three parts together, and this will be the area of the green shape. The first part of the green shape will be A1, that is the area of the right triangle APO, and the second part it will be A2, that is the area of the right triangle OQB, OQD. And the third part will be A3, that is the area of rectangle PQDC. The area of the area A1, that is the area of the right triangle APO. What is the area of A1? I copied the right triangle APO in this new page. AP equals to 12, PO equals to PQ plus QO. PQ is 7 and QO is x, that is 9. So in total PO equals to 7 plus 9, that is 16. So PO equals to 16. So in this right triangle APO, the area of the right triangle equals to AP, that is the base, times PO, that is the height to the base, over 2. AP is 12, PO is 16 over 2. 16 over 2 is 8, and 8 times 12 is 96. So in total, we found out that A1 equals to 96 square units. Then we found out the area of A2, that is actually the area of the right triangle OQD. So I copied the right triangle OQD here, and we calculate the area of this right triangle. QD is x, that is 9. QD is here 12, and QO is 9, it is x, that is 9. So in this right triangle QOD, the area of this right triangle QOD equals to QO, that is the base, times QD, that is the height to the base, over 2. QO is 9, QD is 12 over 2. 12 over 2 is 6, so in total this expression equals to 6 times 9, that is 54. In conclusion, we found out that A2, that is the area of the right triangle QOD, equals to 54 square units, and finally we found out the area of A3, that is the area of rectangle PCDQ. The area of any rectangle is the width times the length. The length is 12, and the width PQ is 7. And in the end, the area of rectangle QPCD equals to PC, that is 12, times QP, that is 7. So the area of 12 times 7, that is 84. So A3 equals to 84 square units. And the area of the green shape, the area of this green shape equals to A1 plus A2, that is A1 plus A2 plus A3. And again, the area of the green shape equals to A1 plus A2 plus A3. A1 is 96, A2 is 54, and A3 is 84. So in total, 96 plus 54 is 150, and 150 plus 84 is 234. In conclusion, we found out that the area of this green shape equals to 234 square units. We finished with the first method. The next step, actually presented to you the second method, how to find out the area of this green shape. In the second method, we joined points A and D together by a straight line. In this way, we created the right triangle ADC. We implemented the Pythagoras theorem on the right triangle ADC. This is the right triangle ADC, this is the chord from the original domain. AC equals to 24, DC equals to 7. So the implementation of the Pythagoras theorem on the right triangle ADC means that AD square equals to DC square plus AC square. So AD square equals to DC square. DC is 7, so DC square is 7 squared, that is 49. Plus AC square. AC is 24, therefore AC square is 24 squared, that is 576. So in total, AD square equals to 49 plus 576, that is 625. AD squared equals to 625. We took out of this equation and finally found out that AD equals to the square root of 625, that is 25. The hypotenuse AD of this right triangle equals to 25 units in its length. Then we completed the quarter circle to a circle. Point O is the center of the circle. Point A is the point of the circle itself. Therefore, OA is the radius of the circle that we defined as R. We extended the radius AO until it touches the circle at point M. So AM is a chord that passes through the center of the circle, that is to say from point O. Any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AM is the diameter of the circle, that is equal to 2R. Why? Because AM equals to AO plus OM, that is also R. AO is R and OM is R, because OM starts from point O, that is the center of the circle, and that ends at point M, that is the point on the circle itself. This is exactly the definition of a radius. So OM is also the radius, exactly as AO. So in total, AM equals to 2R. That is exactly the diameter of this circle. So I found out that AM is the diameter of this circle. Then we extended side CD by a straight line until it touches this circle. Actually, the extended CD must touch the circle at point M and not in any other point. Why? Because if we assume that the extended CD will touch the circle at another point, for example, for this point, that is, for example, point N, then to contradict rule number 5, because we will have peripheral angle ACN that is equal to 90 degrees, and still it doesn't rest on AM, that is the diameter of the circle. It rests on AN, that is not the diameter. But because of the fact that this peripheral angle ACN equals to 90 degrees, it must rest on AM, that is the diameter of the circle. Otherwise, it contradicts rule number 5. Therefore, the extended CD must touch the circle at point M and not in any other point. Okay, so here CDM is one straight line, because we extended the straight line CD by straight line and it touches the circle at point M. CDM is one straight line. Therefore, CDM equals to CD plus DM. CD is 7 and DM is 25, so in total CDM equals to 7 plus 25, that is 32. AC equals to 24, and AM it is the diameter, that is 2R. So I copied the right triangle ACM in a new page and we implemented in this right triangle ACM the Pythagoras theorem. This is the right triangle, but here we have the right triangle ACD. In the right triangle ACD, we have already found out that the hypotenuse AD equals to 25. Here, the hypotenuse AD of the right triangle ADC equals to 25. Then we implemented the Pythagoras theorem on the right big triangle ACM. But before that, we actually proved that those two right triangles can go into each other. First of all, because of the fact that AOB is a quarter circle, this angle will be always equal to 90 degrees. So if you focus on this side of the diameter AM at point O, the sum of the angles must be equal to 180 degrees, therefore the missing angle here must be equal to 90 degrees. So in these two right triangles, AO equals to OM. They are both the area of the circle, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, DO equals to itself. It is a common side that belongs to both triangles. So we prove that those two right triangles can go into each other according to side angle side rule, and therefore AD must be equal to DM. AD must be equal to DM. AD equals to DM according to the rule that corresponding sides in congruent triangles are equal to each other. Those two right triangles can go into each other, therefore the corresponding sides AD and DM must be also equal to each other. Therefore AD equals to DM, but AD is 25. We only found out that AD is 25, so can I take that AD is 25, and from this equation 25 equals to AD equals to DM, and derive that DM is also 25. Here DM equals also 25. Again, and therefore CDM in total equals to CD plus DM, that is to say CD is 7 plus DM, that is 25, so in total CM equals to 25 plus 7, that is 32. So here CM equals to 32, AC equals to 24 units according to what is given as the equation, and AM is the diameter of the circle, that is equals to 2 times the radius, 2 times R. So implemented the Pythagoras theorem on this right triangle ADC according to the Pythagoras theorem. AM square equals to AC square plus CM square. AM is 2R, therefore AM square is 2R square, that is 4R square, and it is equal to AC square. AC is 24, therefore AC square is 24 square, that is 576, plus MC square. MC is 32, therefore MC square is 32 square, that is 1024. In total, we found out that 4R square equals to 576 plus 1024. In total, it is equals to 1600. So finally we found out that 4R square equals to 1600. We divided this equation by 4. 4R square over 4 is R square, and 1600 over 4 is 400. So in total we found out that R square equals to 400. We took a root out of this equation, and finally we found out that R equals to the square root of 400, that is 20. Here R, the radius of this circle R equals to 20 units in its length. Then we implemented the Pythagoras theorem on the right triangle AOD. On the right triangle AOD, AO is the radius that is 20, AD is the diameter that is 25, OD is the missing side. According to the Pythagoras theorem in the right triangle AOD, AD square equals to AO square plus OD square. So AD is 25, therefore OD square is 25 square, that is 625, and is equal to AO square. AO is 20, therefore AO square is 20 square, that is 400, plus OD square. We subtracted 400 from this equation and found out that 625 times 400 is 225, that is equal to OD square. Here we took a root from this equation and finally we found out that OD equals to the square root of 225, that is 15. Finally we found out that the length of OD is 15 units. Now it is very easy to find out the area of the green shape. The area of the green shape will be equal to the area of the right triangle AOD that we defined as A1 plus the area of the right triangle ADC that we defined as A2. So in total the area of the green shape equals to A1 plus A2, that is the sum of the areas of those two right triangles, AOD and ADC. So what is the area of the right triangle AOD? The area of the right triangle AOD, this right triangle AOD equals to the base that is 15 times the height that is 20 over 2. So A1 equals to 15 times 20 over 2. 15 times 20 is 300, and 300 over 2 is 150. So in conclusion, we found out that A1 equals to 150 square units. Then we found out the area of A2. A2 equals to the base that is 7 times the height that is AC that is 24 over 2. So it is 7 times 24 over 2. 24 over 2 is 12. So in total this expression equals to 12 times 7, that is 84. In conclusion, found out that A2 equals to 84 and A1 equals to 150. So the area of the green shape equals to A1 plus 82. A1 is 150 and A2 is 84. So in total, the area of the green shape equals to 150 plus 84, that is 234 square units. Again, I repeat that the area of this green shape equals to 234 square units. Okay, thank you very much.